This talk is outage database development with Spring Boot and Liquibase. My name is Barrington-Hughes. My co-presenter is Pavi Ramaswamy. We're from Premier Healthcare. Back around the submission time, I spoke to my boss, and he said the talk should be about delivering business value. And then I came and I spoke to my team, and they said, no, I think the speech should be about delivering better tech. And then I spoke to my dad, and he said, no, your talk had better be about 30 minutes. These people have got beers to drink. So let's get started. So today, we're going to go and tie together several concepts to perform a no-outage deployment, which includes potentially disruptive database DDL changes. The topics we're going to touch upon will be blue-green and canary deployments, Agile database development concepts. I'll introduce you to a framework called Liquibase that we use. We'll demonstrate embedding Liquibase and the database changes within Spring Boot. And we've already done our sacrifice to the demo gods, so hopefully a live demo at the end. So blue-green deployments, the central tenets, you'll have two distinct versions of your code-based infrastructure. They'll be fronted by a router. One version, customer-facing, that's live, we'll call that blue, and the other one is dormant, and we'll call that green. So green acts as your stage into which you deploy your next release. Upon your warm and fuzzy sign-offs and you're happy with it, the router, you instruct it to redirect the traffic over to green. Blue becomes your dormant standby system, and your green is now live. So your following release, you can use blue as your stage, and your customer-facing, which is now green. And you can toggle back and forth and so on. It's handy, it gives you a nice rapid mechanism to roll back. Canary deployments, in this case you'll have many instances of the code-based infrastructure, and they're fronted by a router, and all the systems are up and running in parallel. And rather than a complete cutover, only a small portion of the instances are upgraded with the new code. And then as you gain more confidence in the new release, and more instances are upgraded and receive more traffic until the old version becomes dormant and no longer there. So thinking about database considerations it can be often a challenge with these techniques, especially when you have to change the schema to support new features and new versions of the software. So the trick is to apply database refactoring changes to the schema to support both the old and the new version of the application at the same time. So first we deploy the canary or the green build, and we check everything's fine, so you do have a rollback point. And then as you're happy, you roll out the new version of the application. And then when everyone's upgraded and the upgrade is bedded down, you can come around and remove the database support or the shim for the old version. So Agile database development concepts, instead of producing a large feature release, which can be high risk, introducing lots of changes at once, and are more likely to require a deployment outage, you refactor your database in small and more frequent feature releases. They'll be lower risk, they'll be more manageable, and because the changes are smaller, more manageable, you're able to deploy them more likely without an outage. So developers are already used to the refactoring of code. You get a feeling when code smells. Databases can smell as well, and they're ripe for refactoring. So if you're thinking you need to make a significant change, try and break it down into smaller steps and complete them over smaller changes. So we'll talk about some structural changes and how we would do that in an Agile database development way. So we're going to rename a column. Potentially, we need to do it to increase the readability of our schema, or we have some enterprise naming conventions that we're not conforming to. So we'll go ahead, we'll introduce the new column, migrate the old data, and then we're going to introduce a synchronization trigger that will keep the old data and the new data in sync. And then after a deprecation period, it might be hours, it might be days, after all the new clients have moved on to the new version of the new schema, we can come around the back, drop the old column, and remove the trigger. You might need to move a column from one table to another. You might do this to increase the normalization, increase your data, reduce your data redundancy, or there might be a use case that you need to denormalize and remove a common join to speed up your code. So before you'll start, you'll need to identify your insertion, your deletion rules. So what happens when I insert into table A or I delete from table B? What are the business rules that I'll need to propagate back and forth? And then you can go ahead, introduce your new column into the new table. You can migrate your data over, and then you introduce your triggers to keep the two tables in sync. Keep that data available to the old version of the code and the new version of the code. And then again, after a deprecation period, everybody's up on the new schema, everybody's using the new column in the new table. We can come around to drop the original column and the corresponding triggers. Or you might need to take a multi-purpose column and split it into several different columns. So you started off with name, and now you want to have your data more granular and break it out into first, middle, and last. Or you have a status field that now has become overloaded, and you need to break it out into several columns. So you'll introduce your new columns. During your data migration, this time you may need to introduce a stored procedure along the way that knows how to decompose your name into its constituent parts. And likewise, if people, when you're inserting into the first, middle, and last name, you might need a transformation procedure to bring it back to the old column and the concatenated name. And you'll introduce triggers again, refactor your application code, and then you can see a pattern kind of identifying here after a deprecation period. When everybody's up on the new version of the schema, you can come along, drop the original columns and the triggers. So some lessons learned. We need to, smaller changes, much easier to apply. It's very useful to uniquely identify every one of your refactorings so that you can see what happened, by whom, and when. Using triggers, overviews for data synchronization. Your database may support updatable views. It's unlikely that it'll do it for views that join. So while there is a processing overhead for using triggers, we've found it to be more easy to manage. And then make sure that all of this is under change control. So we use a tool called Liquibase. It's essentially a scripting language. It runs in Java, and we use it to control all of the modifications to the schema of our database. In fact, we don't let the database change unless it's being done through Liquibase. It records every change that's made to your database, so no change is forgotten. You have a record of everything that happened, so you can look back, and it has some tools for producing database documentation, so you can see who changed what and when and why. It gives you the ability to roll back changes and roll them forward again. So if you have a release that's not going well, you're able to mark a point back, and as you additively apply changes, Liquibase is able to additively revert them. Has out-of-the-box support for a lot of databases. It's extensible, so if you happen to use a JDBC-driven database that it doesn't support, you can create an extension. We used Netezza as one of our databases, and Liquibase doesn't support it out of the box. So in a couple of evenings, I was able to create an extension to Liquibase and allow it to speak and communicate with Netezza. So it's pretty easy to do. So when Liquibase runs, it has a list of changes that you want it to potentially apply. So it takes a snapshot of what the schema looks like right now, what changes have already been applied. It deducts that from the changes that you would like to apply, so it just identifies the delta that you would like to apply. It also looks through the history to make sure that what you changed is still valid. So you haven't been messing with your changes in your code base that have already been applied to the database. Every change is atomically applied, and it has a mechanism to ensure that there's only one instance can be upgrading the database at a time. And again, it records every change that's made. So it has a hierarchical form of change logs. These are just collections of change sets. And then each change set, we try and put as few changes as possible in each change set. And then inside of it, it has individual changes, individual refactorings that you're making. So as you're building your changes to the database, it's good to think in small additive changes. So, just add the column and then just add the index. Don't add the column and the index together because, if one fails and the other one doesn't, it just makes your life a lot more simple to have small additive changes. It has a markup language which you can code in YAML, JSON, or XML, and it will take that markup language, detect which database you've connected to, and it will create the SQL for you. We had a project that connected to several databases and had some common tables across each, so we could just apply the same markup language to both Oracle and Postgres and Netezza, and when the change set ran, it would create the vendor-specific SQL. And then, if needed, break glass in case of emergency. Liquibase can automatically roll back those changes. And if you've used the markup language, because it created the SQL to apply the change, it knows how to create the SQL to do the rollback as well. So these are just a sample of some of the DDL changes that it's able to provide markup for you to use. So creates tables, procedures, primary keys, has the ability to extract out a column into a new lookup table and put in the index, the foreign keys. We use it to manage all of our store procedures, our views and triggers, and it has the ability to load static data reference tables with references to CSV files, and we also use it to manage our test data as well. So you can trigger certain files to be loaded in certain environments. So how do we get Liquibase embedded within Spring Boot? So there you go. That's the code. That's all you need. Well, there's a little bit more. You just need to supply a dependency. So Spring Boot automatically senses that Liquibase is on the class path and will look for your first change set in your source main resources, db changelog master YAML file. And then it just kicks off by itself. Of course, you need to have a database to migrate, so you would just provide your database information. So at this point, I'm going to hand over to Pavi here, who's going to take us through our live demo.
Thank you, Alan. Now, with the wealth of information we have about the Agile database development pattern, let's launch this demo with 2 Spring Boot nodes that share a common database and are load balanced using nginx. The primary function of the application that we would see is very minimal. It captures minimal user information such as first name, last name, and email address of the user. The goal of the demo will be to move the email address column from the user info table into a table of its own so that we can enhance the application to capture more than one email address for a user. There are 3 notable stages in this demo for us to accomplish what we are trying to do here. So the first would be the deployment of version 1.1. And this deployment includes the initial table creations and the application code related to that. The second would be to deploy the version 1.1 of the code, and this would be deployed to one of the nodes. And this deployment includes creating the new the changes related to creating the new table that will hold the multiple email address, the changes related to migration of data from the old email address column into the new table, and a trigger in place that will keep the data in sync so that when any of the older applications keep inserting data into the old column, this trigger will keep the data in sync for the new application to start reading it. In this stage, we will notice that version 1.0 and version 1.1 of the application coexist and run in parallel against a new schema. As a final step, once we know that all the nodes have been successfully upgraded to version 1.1, we are now safe to drop the redundant columns and the triggers. So that being the goal of the demo, we'll start with the script executions. So here you go. To begin with, against the Docker container, we will install the Postgres database. So that's a command to execute that. And then we will install version 1.0 on node 1. And then we'll install version 1.0 on node 2. We will also install nginx. Here, when we take a quick look, we can see that all these containers are successfully running against the Docker. And now let's take a quick look at the installation to see what Liquibase executed. Okay, I'm going to highlight this section so that it's more readable. Okay, there you go. So you can see that when Liquibase started executing, it acquired the lock against the database, thereby keeping the transactions, the nature of changes atomic. And then, as is the very first execution against the database schema, it created a table called database change log. This table is where the historic information about all the change sets that execute through Liquibase are recorded. So we can refer to this table at any time to look what got executed, when it got executed, and who executed it. And then Liquibase starts executing the change sets. The very first change set was creation of the user info table, and then it created the sequence, and then it added the primary key. So any other changes that has been specified in the change log would automatically get executed. And then finally, when it successfully completed all the change logs, it will release the lock against the database. Okay, we'll take a quick look at that. Okay, here is the application that's been load balanced. So we have version 1.0 running on node 1. And then when I refresh, okay, so we have version 1.1 on node 2 also. We'll make a quick data entry here. I don't know, the network seems a little slow. Let's wait for the page to be. Okay, there you go. The entry was successful. Now, we will go ahead and install version 1.1 against one of the nodes. We'll take node 1 for this time. So here we are executing version 1.1 against node 1. I'm going to give it a moment and launch the UI. So here we see that version 1.0 still continues to be on node 2. And okay, and version 1.1 is running on node 1. So if we take a quick look at the logs from version 1.1 execution, we can see that when Liquibase executes, it went ahead, acquired the log as before, and then it started creating the new tables for capturing multiple email addresses. It added necessary primary keys. It added some custom SQLs. So these are the ones that are for creating the triggers, custom SQL triggers. And then it dropped the constraints against the primary column because it can be nullable with this release. And then you can see that it had created for other foreign constraints and things like that. Now, if we launch version 1.0 of the application, so version 1.0 is still on node 1. So we'll try to make an entry here. So let's try to add one more email address. But if you see, it'll not make an entry because this version of the application does not support that. Oh God, still not done. Oh God, sorry about that. Okay. I think because it was a text entry, I think it automatically entered that, but normally it doesn't allow that. So if I launch version 1.1. So here we have I think there's something wrong with the version because this is not the version. Okay. I think something is wrong with our demo. Something has gone wrong. I'm sorry about that. Yeah. So.
Maybe our sacrifice wasn't quite good enough.
Okay. Well, all we can see that though we are running on the version 1.1 of the application, the entries that we made against version 1.0, it still shows up perfectly fine. And finally, we will upgrade the version, upgrade the node 1.1, the node 2 also to version 1.1. So if you notice here, we can pass in extra Liquibase specific parameters here. So now that we are only running with version node 1 and node 2, this is the final run. So I know that the version 1.2 has been validated, it's successful. By passing this extra parameter to Liquibase, I can tell Liquibase to execute extra scripts that can go ahead and drop the old columns and the old triggers. So let's take a quick look at the log for that. Okay, there you go. So here's the change log. So because we asked it to clean up, it started executing the scripts related to the cleanup, and the custom sequels that got executed are the one that dropped the triggers, and the final execution is also to drop the old email address column from the user info table that's no longer needed. So. Okay, here's to show that now version 1.1 runs on node 2. Okay, so I think node 1 we already verified. It's just taking such a, yeah, okay, we can see that version 1.1 run on nodes 1, and that's being load balanced. Okay, there. That concludes the demo. Thank you so much.
All right. Thank you, Pavi. All right. So apparently, yeah, we didn't sufficiently serve our demo gods, but I think we got through. most of that. So I've included a few footnotes. There's some good information on blue-green deployments and canary releasing, a link to Liquibase. There's a great book, it's an oldie but a goodie, called Refactoring Databases. I've got the ISBN up there, so you can go look that up. That has a lot of good Agile recipes for refactoring databases. And there's the GitHub for that demo, which has been working flawlessly until right now. So thank you so much for attending this session. We're from Premier Inc. and yep, you know, we're hiring, so send us a tweet. So thanks very much for your time.